Welcome back to the Neural Intel Pod. Today we're going to go deep on a paper that could totally change how we design the millimeter waves and terahertz circuits.
Yeah.
These are going to be super important for the future of like wireless tech and high-resolution sensing and stuff.
Yeah.
We're talking about deep learning-enabled generalized inverse design of multi-port radio frequency and sub-terahertz passives and integrated circuits.
Yeah.
Um,
Wow.
It's a mouthful, I know. Get ready, though, because this is where AI starts designing circuits in minutes instead of years.
Yeah, what's so cool about this paper is that it really tackles this problem. Designing these high-frequency circuits is such a pain.
Oh, it really is.
It's so difficult, and it takes forever.
Yeah, it really is like you're working with these microscopic tools, and you're just like tweaking every tiny component, running simulations, and then you just keep doing that over and over until it's right.
Yeah.
And, with the traditional methods, you're kind of stuck with these preset templates,
Yeah.
which really limits what you can design.
Totally. The traditional process is so slow, and it really depends on the designer's intuition and like a lot of trial and error.
Yeah.
You're just basically optimizing existing designs instead of looking at a whole new world of possibilities.
And that is where deep learning comes in, right?
Right.
These researchers used AI to design like arbitrary-shaped multi-port electromagnetic structures.
Mm-hmm.
They're not just tweaking what we already have. They're venturing into like designing totally new circuit layouts.
Yeah, that's the breakthrough here. It's like giving AI the ability to just think up and sketch out these like blueprints for circuits that really push the boundaries of what we can do.
Okay, so how does this actually work? What's the magic behind it?
So the key is a deep convolutional neural network, or we can just call it a CNN. They basically trained a CNN to be an electromagnetic emulator.
So they don't have to run all those time-consuming simulations to figure out how a circuit design will behave. They have this AI that can just do it instantly.
Yeah, basically. The way they trained the CNN is cool too. They used something called transfer learning, which is like leveraging existing knowledge.
So transfer learning is basically giving the AI a head start in understanding circuit design.
Pretty much. It's like starting the AI off with the basics of circuits and then refining that with specific examples. So in this case, they started with this big data set of low accuracy simulations, which are faster to make. And then they fine-tuned the CNN with a smaller set of high accuracy simulations.
Smart move.
This way, they can train the model quickly without losing accuracy.
I bet transfer learning also makes the model more versatile too, right?
Yeah.
So it can be used with different like chip fabrication processes or frequency ranges.
Totally. That's one of the big advantages of transfer learning.
Yeah.
It's adaptable. And they also did something called data augmentation, which is like creating variations in the data to help the model learn even better.
So it's not just like throwing any data at the AI. You got to be smart about it. I see why they're getting these awesome results. And they tested this thing outright. They designed different structures and compared what the AI predicted to actual simulations.
Yes, and the results were spot on. They tested it with everything from antennas to these complex multi-port networks, and the AI's predictions were right there with the simulations.
It's crazy how well it can predict how these circuits will act.
Yeah.
But how do they actually go from like wanting a circuit that does something specific to getting the layout for that circuit? How does this inverse design thing work?
This is where it gets really cool.
Yeah.
So they take the AI and its predictions and they combine that with an optimization algorithm.
Okay.
Specifically, they use a genetic algorithm. Think of it as like a search through a huge map of circuit designs.
So AI is like an explorer going through this unknown territory, searching for the perfect design.
Exactly. The genetic algorithm starts with some random designs and tests how well they perform using the AI. And then the best ones get to breed, so to speak, creating new and improved circuits. This process goes on until they get a design that does exactly what they want.
It's like survival of the fittest, but for circuits. And what's even more amazing is that the AI can actually design things that are better than the stuff they use to train it. That means it's not just copying, it's really learning and innovating.
It's not just mimicking what it's seen before, it's really coming up with new stuff. They even went a step further and actually built some of these AI-designed structures in the real world, like bandpass filters, quadrature hybrids, and even multi-band antennas.
Wow.
And the real-world results matched their predictions perfectly.
So it's not just good in theory, it actually works in practice. That's super impressive.
Yeah. But they didn't stop there. They actually used this technique to design a working amplifier.
No way.
Yep. This is where you can really see the power of this multi-port inverse design method. They designed a two-stage broadband millimeter wave amplifier.
Hold on.
And they use these unusual, irregular structures that traditional methods would have a hard time even imagining.
So they're not just designing components anymore. They're designing entire circuits with like complex functions.
That's right. And the results are awesome. They got a measured gain of 17.5 to 14.5 DIs over frequency range. That covers most of the 5G bands we use. That's a huge accomplishment, especially at those high frequencies.
All right, so walk me through how they use this approach to design the amplifier. What were the big steps?
So first, they came up with a new architecture for the amplifier. It uses this asymmetrical power division at the input and a phase compensating combiner at the output.
Okay.
It's unusual, but it let them explore a whole new world of design possibilities.
So breaking away from the traditional symmetrical designs was key.
Exactly. Then they used their inverse design method to create the asymmetrical three-port structures for the input splitter and the output combiner. And
Yeah.
they did this while thinking about the active circuit amplifiers that were going to be connected to these things.
Gosh.
Which is really important because in the real world, all these parts interact with each other in crazy ways.
And especially at high frequencies, that gets really complicated.
Yeah, exactly. Traditional methods often look at each part in isolation. They optimize each one without thinking about how they'll all work together,
Yeah.
and that can really limit the performance.
But with this new AI-driven method, they're looking at the whole picture, right?
Exactly. They're designing everything together to get the performance they want overall.
This is seriously groundbreaking stuff.
Yeah.
Before we wrap up this first part of our deep dive, I'd love to hear your thoughts on the bigger picture. What does all this mean for the future of circuit design?
That's a big question. I think this research shows a huge shift in how we design and build circuits, especially the complex ones. Traditionally, circuit design has been this super specialized field. You really had to rely on human expertise and intuition. But with this AI-driven approach, design automation is going to be so much more important.
So you're saying we might see AI designing the chips that are in everything in the future? Our phones, self-driving cars, medical devices, everything.
Absolutely. And not just designing them, but designing them faster, better, and with performance we've never seen before. Just imagine. Smaller devices that are way more powerful. That's the future this tech could bring. We'll talk more about what this all means in part 2. So one of the cool things this paper talks about is how this tech can be used for way more than just matching networks. Like, it really opens up a whole new world of what we can design and what these circuits can do.
I know, that's what I'm so excited about. Like AI is going to be designing chips that can do things we haven't even thought of yet.
And it might happen sooner than you think. The researchers were talking about how fast this method is. Designs that used to take weeks or even months could now be done in minutes.
So we're not talking about like small improvements here. This is a whole new way of doing things.
Totally. It's like going from drawing blueprints by hand to using a computer. It could really speed up how quickly we can make new stuff in wireless communication, sensing, and maybe even computing.
It's not just about speed, though, is it?
Yeah.
It's also about being able to design things that we couldn't even imagine before.
You got it. And the researchers showed this perfectly when they designed that broadband millimeter wave amplifier using asymmetrical structures.
Yeah.
Those designs would be a nightmare to create with traditional methods, but the AI just whipped them up and they worked amazingly well.
It's almost like the AI is breaking free from how we humans think about design and exploring new possibilities.
I like that. That's really what makes this research so special. It's not just automating what we already do. It's creating a whole new set of possibilities where circuits can do things we never thought possible.
I'm all in on this AI design revolution. But let's be real for a second. There's got to be some limitations, right?
Of course, nothing's perfect. One thing is that it takes a lot of computing power to train these deep learning models. You need a ton of data and processing power.
That makes sense.
Yeah.
We're basically teaching these AIs to be experts in electromagnetism.
Exactly. But computers are getting more powerful all the time, so that will become less of a problem. Another thing is that it's hard to understand why the AI makes certain choices when designing something.
So it's kind of a black box. We know it works, but we don't know exactly how it's thinking.
Pretty much. But
Yeah.
they're working on that. There's a lot of research on making these models easier to understand.
That's going to be important if we want to really trust these AI systems to design critical stuff.
No doubt. But even with those challenges, this tech has a ton of potential. It could change how we make electronics and bring a wave of new innovation.
So for our listeners out there, what does this all mean? Well, this research could have a huge impact on a bunch of industries. Faster, more powerful chips could lead to better smartphones, self-driving cars, medical devices, and so much more.
It's exciting to think about all the possibilities. And if you want to learn more about this AI-driven design stuff, check out our webpage. We have links to all the latest research and articles on this and other cool topics.
This deep dive has been super interesting. I can't wait to see what happens next with AI circuit design. But before we get too far ahead of ourselves, we still have some more cool details from this paper to talk about, like how they tackled multi-port structures and made a truly generalized inverse design method. We'll get into that in part 3 of our deep dive.
So like we were talking about before, let's get into how they dealt with those multi-port structures.
Yeah, this is where it gets really tricky, right?
All right.
Because in the real world, circuits have like a bunch of inputs and outputs. It's not just one signal path.
Exactly. And the traditional methods have a hard time with that, especially when you get to high frequencies.
Yeah.
They usually simplify things by breaking the design into smaller chunks, which doesn't always give you the best performance.
It's like trying to put together a puzzle, but you can only look at one piece at a time.
That's a great way to put it. What these researchers did was come up with a method that looks at all the ports and how they work together all at once. They thought about the whole multi-port structure as a single unit.
So instead of just sticking components together, they're designing the whole thing holistically.
Right. And that's where their deep learning model comes in. Remember that CNN we talked about that acts like an electromagnetic expert?
Oh yeah, it's like having an AI that can tell you instantly how a circuit will behave.
Exactly. They use that AI to look at tons of different multi-port designs and find the ones that work the way they want.
So the AI isn't just designing parts, it's figuring out how to connect them in a way that makes the whole circuit do what it's supposed to.
Precisely, and that's what they mean by generalized inverse design. It's a method that works for all kinds of multi-port structures, not just specific circuits.
That's what makes it so cool. It's
Mhm.
not just for filters or amplifiers. It can be used to design all sorts of complex circuits with multiple inputs and outputs.
Yeah, and to show that off, they designed a bunch of different multi-port structures like power dividers, hybrids, and couplers. These are like the essential building blocks for advanced circuits that are used in wireless communication, radar systems, and even medical imaging.
It's amazing how this deep learning stuff is changing how we design circuits. It's opening up possibilities that we couldn't even imagine before.
I know, it's really exciting, and it's not just about designing single circuits either.
Yeah.
This technology could help us develop whole systems faster, from the chips in our phones to the huge networks that connect everything.
It really makes you think about the future of electronics. If AI can design circuits better and faster than humans, what does that mean for engineers?
That's a good question, and people are talking a lot about that these days. Some think that AI will eventually replace engineers altogether, but I think it's more likely that AI will become a tool that helps engineers do their jobs even better.
So instead of replacing engineers, AI will help them be more creative and come up with new ideas.
Exactly. AI can handle the boring and time-consuming parts of design, and that frees up engineers to focus on the bigger picture, like coming up with new architectures and exploring new concepts.
That sounds like a good deal. AI does the hard work, and humans get to be the creative geniuses.
Exactly. And in the end, that's what will really push this field forward, the partnership between humans and AI.
This deep dive has been so interesting. We've learned so much about how AI is changing circuit design and what it could mean for the future of electronics.
Yeah, it's been fun.
If you want to learn more about all this stuff, definitely check out the full research paper and our webpage. We've got a ton of resources there.
You'll find the link in our bio.
Thanks for joining us on this journey into the world of AI-powered design. Until next time, keep exploring and keep learning.